Right, okay, let's move on to collections. Right, we start with list. A list in Python really is an ordered collection of objects that can contain any data type. We define a list using bracket, all right? Not the this bracket, but the square bracket. So here in our list, we have 3 items or 3 objects, 1, 2, and 3. So when I print it, I have 3 objects. We can access and also index the list by using brackets as well. In order to select an individual element, simply type the list name followed by the index of the item you are looking for in the braces. So here, my list, which is this one here, and bracket 0. Now, Python start counting from 0. So the 0 really is actually 1. So 0 here, actually, my list 0 refers to this item, number 1. 2 here really refers to item number 3. So let's print it and see whether it works out as we say it would, and sure enough, it does. So indexing in Python starts from 0. If you have a list of length n, the first element of the list is at index 0, the second element is at index 1, and so on and so forth. The final element of the list will be at index n minus 1. Be careful, try to access a non-existing index will actually cause an error. So here, if we print the first, second, and third list element, okay, we'll do it this way, and print accessing outside the list bounds will cause an error. So let's see if it runs both at the same time. Quite likely we'll print the first one and give you an error for the second one. Okay, sure, it does do that. Okay, it prints the first, second, and third list elements, these 3, and then once it actually go to run the second line, it will give an error. Okay, the list is not that long. Hello. Okay, so yeah, so we can see that the number of elements in the list by calling the length. Okay, so that's how you actually check it out, just looking at the actual length itself. Okay, so len bracket function. So if you print my list, so let's come back to my list. Okay, remember my list contains 1, 2, and 3. Okay, so if you actually run this, print it to the screen, what do you get? You get 3 because we have 3 items in the list itself. We can update and change a list by accessing an index and assign a new value into it. So let's print my list again, and here I want to store 42 into the my list, and then print the list, and should change now. No longer would it be 1, 2, 3. It's most likely going to become 42 and then 2 and 3. Let's run and see. Okay, there we go. It prints the original list, which is 1, 2, 3. And now when it print the same list again, because we already assigned 42 to the first item, it becomes 42, 2, and 3. So this is fundamentally different from how strings are handled. A list is mutable. Mutable here is really a fancy word, means you can change it. Meaning that you can change the list elements without changing the list itself. Some data types, like strings, are immutable, meaning you cannot change them at all. Once a string or other immutable data type has been created, it cannot be directly modified without creating an entirely new object. Right, we are looking at my string now, or string as a data type. So strings never change, so we store that into this variable called myString. So if I force the first character of my whole string to Z or Z, you will get an error. So let's run this. There we go. It does not like it. Okay, and it gives you this type error. String object does not support item assignment. As you can see, the error message is not very informative. So the best way is, once you encounter this a few times, remember them. Next time when it pops up, especially when you're writing long codes, and when this pops up, then you will remember this has to do with the fact that you're trying to change the individual value of a string itself. As we stated before, a list can contain any data types. Thus, list can also contain strings. Okay, so my list too contains strings. So if I print that, and this is what you get. And list can also contain multiple different data types at once. That's really why list is so popular and so powerful. Okay, and it stored this, but we didn't print it out. So how do we print it out? Let me just add a new line. We always want to check my list 3. Okay, and run that, and it will give you truth, and 42. Oh, sorry, truth, false, and 42. And the truth here is a boolean, false here is actually string. Don't be fooled, because it does actually have those single quotation mark, and finally 42 is an integer. So if you want to put these two lists together, which two? My list 2, my list 3, they can be combined with the plus symbol. My list 4 is going to be my list plus this. When I print it, it should be one long list. Okay, that makes list very, very powerful, extremely flexible for you to play with. In addition to accessing the individual elements of a list, we can access groups of elements through slicing. So here, let me just push this up so that you can see the whole thing. Here we store this 1, 2, 3, 4, 5, 6, 7. We're storing this 7 so-called strings into this list called my list. If I run that, okay, it's stored in there. You won't be able to see anything because we didn't print it onto the console itself. Slicings. We use the colon to slice list. So here we want to print 2 to 4. Basically, this is saying starts from number 3. Okay. So in this case, countryman until land. Okay. So let me just print this so they can understand what I'm talking about. So remember, Python start counting from 0. 0, 1, 2. So it starts from 2, 3, and it stopped. Okay. Or this 4 basically saying stop before 4. Starts at 2, stop before 4. Okay, it used to confuse me, but it's okay now. So once you get the hang of it, you know how it works. It's not too bad. Using colon, we can select a group of elements in the list, starting from the first element indicated and the growing up, but not including the last element indicated, which is what I just illustrated. We can also select everything after a certain point. Here we select from 1 onwards, which is item number 2 or list number 2. From Romans onwards, if we run that, here we go. We have everything. And everything before a certain point by putting colon before 4. So if we run that, so it's basically 0, 1, 2, 3. Okay, it doesn't include 4. Using negative numbers, we'll count from the end of the indices instead from the beginnings. For example, an index of -1 indicates the last element of the list. Here, if I run this, it should give me years. You can also add a third component to slicing. Instead of simply indicating the first and final part of slice, you can specify the step size that you want to take. So instead of taking every single element, you can take every other element. How do you do that? So you start from 0 all the way to 7, excluding 7, of course, and stepping 2, okay, at a step of 2. And we have starting from 0, skip this, 2, countrymen, skip this, and then me, skip this, and then years. Here we have selected the entire list because 0 to 7 will use, Here we have selected the entire list. 0 to 7 will yield elements 0 through to 6. And we have selected a step size of 2, so this will spit out elements 0, 2, 4, and so on through the list element selected. We can skip indicate at the beginning and the end of our slice, only indicating the steps if we like. Here, we don't specify the beginning to the end, we just specify the actual step itself. And lists also implicitly select the beginning and the end of the list when not otherwise specified. If you just put a column like that, that means everything is selected. With the negative step, we can even reverse the list. So nothing specified in the beginning, nothing specified at the end. We just put a -1, and if you run this, it go backwards. All right. Python does not have a native matrices, but with list we can produce a working facsimile. Other packages such as NumPy add matrices as a separate data type, but in base Python the best way to create a matrix is to use a list of a list. Okay, so in the future we'll talk about NumPy a little bit more, but in this we just want to give you a gentle introduction to Python. So we can use a built-in functions to generate a list. So let me just push this up. In particular, we will look at range bracket because we will be using it later. Range can take several different inputs and will return a list. So here we have b equal to 10. My list is equal to range bracket b and print my list. So basically range just count from 0 onwards. Okay, let's run this. The range provides 0, 1, 2, 3. It generates a list. In that sense, it counts. Sorry if that confused you. So if you print it, similar to our list slicing methods from before, we will define both a start and an end to our range. This will return a list that includes the start and excludes the end, just like a slice. So moving on to this cell, A is equal to 0, B is equal to 10. My list, we're specifying a range now, start from 0 all the way to 10, excluding 10 of course, and then print it out. We can also specify a step size. This again has the same behavior as a slice. So just run this, and here you go. It's skipping 2. Why don't we just change this? The beauty of Python is that you can play around with this, you won't break it. And when you do this, you get a much better intuition. Alright, so notice the step size is 3 now. So play around with it. That's really what I find for me works, is just play around until I get the hang of it. So let's move on to the next data types called tuples. A tuple is a data type similar to a list in that it can hold different kinds of data types. The key difference here is that a tuple is immutable. Remember what immutable is? Immutable means you cannot change it. We define a tuple by separating the elements we want to include by commas. It is convenient to surround a tuple with parentheses. Okay, my tuple, okay, is this. So let's just run it. Okay, see the bracket? All right, and let's run this again and notice that they are exactly the same. So it's common to actually have a tuples with a bracket. Okay, as mentioned before, tuples are immutable. You can't change any part of it without defining a new tuple. Before I run this, notice that there's actually a comment here. What does the comment say? Comment says, attempts to change the cat's value stored in the tuple to dogs. Okay, so we're trying to change number 3, which is 0, 1, 2, 3. And if you run that, you're gonna get an error message. Tuple object does not support item assignment. Okay, so you can't save, you can't change it. You can slice tuples the same way that you slice list, like this. So start from 1, stop before 3. Okay, start from 1, have 30. And concatenate them the way that you would with strings. Concatenate really is a fancy word of saying combine. Okay, just combine them. My other tuples make that 50, print my tuple plus my other tuple, again using a plus. Do just combine them, concatenate. We can pack values together, creating a tuple as above, or we can unpack values from a tuple, taking them up by doing this string 1, string 2, string b with this comma. Okay, it will unpack them. So let's just print it out. Okay, let me scroll that up so that you can see the whole thing. Okay, so my other tuple. Okay, let's see if I can see my other tuple here. Okay, my other tuple. Okay, sorry about that. My other tuple is this one. Okay, you have these 3 matching 3. Okay, so it actually spits it out, make that 50. Okay, when you print it, it splits and store them into those individually. So unpacking assigns each value of the tuple in order to each variable on the left hand side of the equal signs. Some functions, including user-defined functions, may return tuples, so we can use this to directly unpack them and access the values that we want. Right, let's move on to sets. What is a set? A set is really a collection of unordered, unique elements. It works almost exactly as you would expect a normal set of things in mathematics to work, and is defined as using braces. Okay, things I like. Okay, so you have a whole bunch of numbers here, just one long list. Okay, when I print it and also print the variable in here and print the type, let's see what it looks like. It's a set. Okay, so wait a second. It's a set. And wait a second, the value here is not the same as the value here. Why is that? You have a 4, you only have one 4, although you have 3 4s here. Okay, notice that what set does, set actually make it unique. All right, only it removes the duplicate altogether, and what you get is just the unique numbers. So note how any extra instances of the same items are removed in the final set. We can also create a set from a list using set bracket function. So you have a list, right? And you have a set, store it into animal set. When you print it, it will remove all of the repeats. So we have dogs, 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 sponges, sponges, gone. Okay, we only have 1 dogs, 1 sponges. Okay, calling len on a set would tell you how many elements are in it. Run that, you have 6. Right, because the set is unordered, we can't access individual elements using an index. We can, however, easily check for membership to see if something is contained in a set and take the unions and intersects of sets by using the built-in set function. So let's do this. Here we are checking whether cats is in the animal set. So if we run that, true, meaning it's in there. So cats, cats. And here we check to see whether the string cats were contained in our animal set, and it returned true, telling us that it is indeed in our set itself. We can connect sets by using typical mathematical set operators, namely union and also and for intersections. Using union or intersection will return exactly what you would expect if you're familiar with sets in mathematics. So here you have animal sets. This is a union. In programming lingo, this is called OR. Okay, OR, OR. Okay, so things I like. So you have things I like, which is these. Animal set, which is these. And when you have an OR, basically you are combining the two. Okay, so you have a union of both. So pairing 2 sets together with OR combines the set, removing any repetitions to make every set element unique. So if we use an AND, basically we are asking for the intercepts. Only lizards and dogs are in both sets. Pairing 2 sets together with AND will calculate the intersection of both sets, returning a set that only contains what they have in common. If you're interested to learn more, learning more about the built-in functions or set, feel free to check out the documentation of Python. It's pretty comprehensive and pretty useful. Okay, so let's just move on to dictionaries. Another essential data structure in Python is the dictionary. Dictionary are defined with a combination of curly braces and also colons. The braces define the beginning and the end of the dictionary, and the colons indicate key value pairs. A dictionary is essentially a set of key values pair. The key of any item or any entry must be an immutable data type. This makes both strings and tuple candidates. Keys can be both added and deleted. In the following example, we have a dictionary composed of key value pairs where the key is a genre of fiction and the value is a list of books, which is a list with that genre. Since a collection is still considered a single entity, we can use one to collect multiple variables or values into one key pair. That's a long paragraph of words. So what does it mean? We look at this, my dic, okay? My dictionary, really. So here you have, this is the key and this is the variables. Every time you see a key is before the colon, okay? And then followed by the list variables. You have the key followed by the dictionary. Okay, sorry, the list, I should say. So let's run this. Let's store everything into my dictionary. After defining a dictionary, we can access any individual values by indicating its key in braces. So here, my dictionary bracket sci-fi, and I run it. It will bring out all of these. Okay, Book of the New Sun, Necromancer, and Snow Crash. Alright, so the sci-fi. We can also change the values associated with a given key. So within sci-fi, we put in I can't read, and now it overrides all of these, and all that we have now is just I can't read. Okay, so the next one is we want to print. We can add a new key value pairs. All right, historical fictions. Notice that there's no historical fictions. That there's weird one. There's sci-fi. There's high. So pillars of the earth store into my dictionary, historical fiction, and when we print it, it is now stored in there. When I print the whole dictionary, okay, here you have historical fiction, pillars, sci-fi, only with I can't read now because we've overwritten all of these. Okay, the rest remain the same.